Now we're recording. Thank you. The first thing I actually want to do is to give thanks to David for his disposition to actually join us and match a bit of our schedules in order to be able to have a joint meeting. So thank you. And I'm really excited about this meeting and to be able to share with you. These are some of my students. Maybe some of them are gonna join a bit later. Some of them are actually working at the moment, so maybe I'm sure that they had to move on things and to be able to join. So I'm really thankful for that too. And well, I remember I actually had to say that because I remember one of the first times I joined, I met with David was in a poker championship or a competition that was a call for statisticians and mathematicians and people from the sector. And we had this amazing random, I must say, because I remember I had one of my friends, he used to play a lot of poker, but virtually. And then we all decided to go together to this competition. And maybe not because we were going to win, but it was a great experience to actually have the opportunity to share and meet people like David Spiegelhalter. So I'm really glad about this meeting because also, well, I did my PhD in Leicester University, and this is one of the most richest experience that I had in my life to be able to interchange and to meet with different types of people. And well, I'm sure that David is gonna tell us wonderful stories today. So I had a lot of questions and I said, well, let's do a long list of questions, but at the end of the day, maybe it's better to leave it open. So, and if well, you decide whether you want to be asked anyway or at the end, or what do you prefer?
Oh, yeah, okay. No, with a really nice small group, I'd much rather people interrupted, put their hands up or something like that. Much better. It's really nice to be able to do something sort of more intimate with a small group of people. Lovely, lovely. Yeah.
Okay, so I'll just be quiet from now on, listen to you.
Okay. Well, I'm going to talk. I'll talk. I mean, I got some slides which I'd like to go through because there's some ideas. Probably about half an hour, but please interrupt and put you can put questions in the chat or just wait and ask me those. So it's very nice. We can do this as a conversation, I hope. So I'm going to share my screen. Oh no, that's the wrong one. That's the right one to share. And the point being also, that's me. I'm retired now from Cambridge, but the non-executive director is interesting because that's the UK Statistics Authority runs the whole national statistics system for the UK. So I've become much more interested in official statistics, the counting the deaths, counting the unemployed and the migration and things like that, which I never was interested in before, but I now realize is incredibly important. So I do more of those kind of things now. But I used to do statistical methodology, difficult things, Bayesian clinical trials, which Milena will recognize, and Bayesian computation and Winbugs and things like that. And that's what I used to do. And it was great. But frankly, after years of this, I was getting a bit bored with it, particularly the writing papers and sending papers in and these stupid referees coming back with their comments. And I thought, no, I've had enough of this. So, and I luckily, a billionaire, really rich man, funded me in 2007 to change my job into a statistical communicator. more a statistical performer. And so I started making TV programs on climate change and making TV programs on chance. And I don't know if you recognize that, the big red balls in Argentina. I was in Argentina, in Buenos Aires, doing Wipeout, and I got on Desert Island Discs, which is the big radio program in the UK, because I did a lot of work during COVID and I became quite well known as a statistical communicator during COVID. And I wrote books, and The Art of Statistics has been successful, about 11 languages. And that's my new book. Now, here it is. And and that's the American version. Hang on, you can't. It's not focusing. Uh,
No.
in front of me knows my face it's recognizing. Anyway, never mind. That's the American version. Um, and it's full up with, I mean, it's really about probability and uncertainty and measuring uncertainty, all the things I've been interested in for years and years. So there's Bayes in there, scientific uncertainty, confidence, predictions, risk, and so on. So I put into it all the things I'm interested in, and I'm just going to do a few of those, well, for me this evening. I'm already on the wine, but you're probably not. But I'm already drinking wine. It's lovely to be able to give a talk while drinking wine. Quite right, too.
Okay, so enjoy it.
Yeah, I am. I am. I'm delighted. I forgot the bottle, but never mind. Okay, uncertainty. I like this definition, the conscious awareness of ignorance. It's about what we don't know. And so I kind of like that idea because it makes it very much a personal thing. Because we may be ignorant about the future, the present, the past, why things happened. But it's essentially it's a relationship between a subject, me or you, and an object, something we are uncertain about. And you may recognize a very strong Bayesian background to this about subjectivity being the basis for uncertainty. So I try to discuss this now without using the word Bayesian. Don't use the B word, I found out. So the book is about deconstructing uncertainty, how to think slowly about not knowing. And the reason I show a coin is that when I'm demonstrating this, and I'll put the camera down a bit, with an audience, I'll take a coin and I'll say, what's the probability? I'm going to flip this coin. What's the probability it will be heads when it comes down? And people say 50-50. They'll say that. And then I flip it and cover it up and say, okay, now what's your probability that this is heads? And people, so they don't like it, but after a while, they will say, yeah, 50-50, I suppose. They don't like it, but they do it. And there's a huge change there. We've changed from what's called aleatory uncertainty about the future, what we cannot know, to epistemic uncertainty about what we do not know. But what I want to show is that probability can be used for both of these things. Probability can be used as a measure of our ignorance. I also then say, have a look at the coin. I don't see it. No, there we are. I'm going to turn it round. And it's a beautiful coin, £2 English coin with two heads. Queen Elizabeth, two heads. So it's strictly illegal and it costs quite a lot, in fact. But it's a beautifully made. And what that shows is that I think quite a deep lesson that even the 50-50 that people say confidently at the start is just relies on assumptions and judgments that I am honest and trustworthy, and maybe I am not. So I use that as a very simple demonstration that any probability we use is a construction based on judgments and our personal knowledge. So, which I shall come back to. Okay. I use stories a lot, and the first one I use a story about why you should try to use probability. Okay, Bay of Pigs, Cuban Revolution under Castro in 1959. The CIA planned an invasion by 1,500 Cuban exiles into the Bay of Pigs. I've visited the Bay of Pigs. Now it's a beautiful, peaceful place with wonderful beaches. But it wasn't then. Now, when Kennedy became president in 1961, he was told of the plan and he commissioned a report by the Joint Chiefs of Staff. And they thought it had a low chance of success. They thought about 30% chance of success, 70% chance of failure. But in the report that went to Kennedy, the numbers were replaced by words, a phrase, a fair chance of success. I don't know how that would best translate into Spanish. They meant not very good, but in English, it suggests quite a good chance. So completely misleading using those words. Kennedy approved the invasion, and it was a total disaster. There is Castro getting off a tank. All um, the invaders were killed or captured. So a massive disaster. So the lesson from that is how dangerous it is in important decisions to use words instead of numbers because they're so easily misunderstood. So it's best to at least roughly define words. So in the UK, if you are in UK intelligence, MI5 or MI6, MI6 is the James Bond outfit, and you use the word likely, you must mean between 55% and 75% probability. And I know that because I've got a mug. I, yeah, I gave a talk at MI5 and all I got was this lousy mug. So I got this mug and it's an official, you know, British intelligence mug that reminds you what words to use for probabilities. And there it's quite clear that if you think something has only got a 30% chance of success, you must use the word unlikely. Must use the word unlikely. And I think this is really powerful and it shows what how people have learned. And the 50 years after the Bay of Pigs disaster, there was another big decision to be made by whether Osama bin Laden was in the compound in Abbottabad 10 years after 9/11. And I just watched a TV program on it. There's lots of evidence he was there, but nothing very strong. Nothing had actually confirmed he was there. And Obama, President Obama, heard multiple numerical assessments of the probability that bin Laden was in the compound. So this was a quote from Obama. Some thought it was only a 30 to 40% chance. Others thought it was as high as 80 to 90%. So people were putting numbers on their probabilities. They were using their judgments with a big variation. The 30 to 40% is quite pessimistic. And he heard all these different opinions and he said it's basically 50-50 he came up with. And he approved the raid and it was the right decision. Well, not for Osama bin Laden, but it was, politically the right decision. And since then, it's been argued whether the intelligence officers should have got together beforehand to produce a single assessment. And I think no, not at all. And we'll see another example of that in a minute. Okay, so the point is that we can assess probabilities, but we need to know how good they are. So I'm going to give you a little quiz. I'm going to give you a little quiz, quantifying your ignorance. So I hope you're ready. You might want a pencil and paper, but you can probably do this in your head. Okay, I'm going to ask you some questions. with answers A or B, and you have to think how confident you are. You have to choose an answer, A or B, which you prefer, but then you have to think of how confident you are between 5 and 10, because I hope you don't know the answers. These are difficult questions. I hope you don't know the answers. Maybe you do. No cheating, no Wikipedia, no phones. Okay. And you score yourself. And this is the scoring rule. So if you say, I'm 10 out of 10 confident it's A, and you're right, you get 25. But if you're wrong, you lose 75. So it's very asymmetric scoring rule. And see if you can spot the pattern in the numbers. I'll show it later. So, first question. Who's older? Which head of state is older? President Trump or King Charles III? Who is older?
B.
Shush.
Me.
Don't say it.
Ah,
Don't, no,
okay.
be quiet. Don't say your answers. Write your write your answers down and how confident you are in them.
Okay.
Yeah.
Not necessarily
Don't shout your
answer.
answers out.
Okay.
Right. Have you chosen? School kids understand this. Okay, so have you chosen your favorite answer? Have you put a number between 5 and 10? And the answer is A. Trump is older than Charles III.
Okay.
Yeah, so Milena, if you said Charles III, 10 out of 10, you've got off to a really bad start to this quiz. Okay, you get the feel. Okay, here next one. Which is the bigger area, El Salvador or Belize? Which is the bigger country? El Salvador or Belize? Which is yeah, these are supposed to be difficult. I wasn't going to choose an easy one. El Salvador or Belize? Which do you think is biggest? Okay, what do you think the answer is? Any options? Anyway, Belize. Only a little bit bigger. It's a bit bigger than El Salvador. So, okay, have you scored yourself? You get the feeling. Right, next one. Which is further west? San Jose in Costa Rica or Chicago? Further west.
Wow.
I know. No, these are supposed to be difficult. There's no point in giving you easy questions. But you got to say, you could say 5. If you just said 5, you
Okay,
just stay
yeah.
where you are.
Oh, yeah, it's true.
Yeah, you can just say, I don't know. And then you stay where you are. No risk of going down or up. Okay. And the answer is, what do you think? Chicago is slightly further west. Pretty close. I deliberately chose one, quite close. Yeah, okay. Chicago's further west. Right. Two more. Right. Which is bigger, Venus or Earth? Is bigger, Venus or Earth? And the answer is Earth is a little bit bigger. Not much, but a little bit bigger. And finally, which is the biggest population? Cambridge in the UK or Cambridge, Massachusetts, where Harvard is? Two cities. Which is biggest? Which is the biggest population? Now, I hope you don't know, but you may. Okay. Have you answered? And the answer is A. Cambridge, UK is a bit bigger than Cambridge, Massachusetts. Not by a lot, but a bit bigger. Okay. So I'm not going to ask you all your scores, but roughly, can I ask, who got, um, did anyone do very well? Did anyone get good positive scores? I don't know. Yeah. Okay. David, how many did you get do well?
Yeah. I got a 43.
Oh, that's very good. Oh, yeah. To get anywhere near 50 is very good on this quiz. Yeah, it's difficult. Okay. So, some people do quite well, and some people are quite cautious and just answer 5, 6, or 7 and stay around 0. And these are people who know what they don't know. Oh, no, yeah, know what they don't know. But some people get very big negative scores. And I'm not going to ask who gets big negative scores, but a lot of people get negative scores. Usually, the majority of people get negative scores on this game. And I always say that a chimpanzee could do better than that just by saying, 5 for everything. So the point is, what this game, it's not actually a game. It's a really serious exercise to teach people about to avoid overconfidence, to have an insight into what they know and they don't know. And so these quizzes are used for training intelligence analysts, for training super forecasters, for training people to make probability assessments. So what is the pattern? Can anyone spot the pattern on it? What you have to do, the maximum score is 25. And so if you look at what you lose for each of these judgments, you lose working downwards, you lose 1 or 4 or 9 or 16, 25, 36, 49, 64, 81 or 100. It's squared error loss. You're losing the square of your mistake. And this scoring was developed by Breyer, an American meteorologist, for scoring probabilistic rain forecasts. It's been going for 75 years. Yeah, really powerful idea. Okay, so what this shows, probability is a strange thing. I mean, we use it all the time in gambling and modeling for confidence intervals or credible intervals. We use it for p-values, insurance, everything. But what is it? What does it mean? What does it mean? It's really strange. You know, when we have numerical probabilities, are they estimates of some true underlying probability? I'm getting a bit philosophical now. Um, is there anything such as a true probability? Does it actually exist in the outside world objectively, or is it always an expression of our subjective judgment? In other words, did we just make up the idea of probability? We just invented it in the 1650s. And I wrote a paper in Nature last year saying, does probability exist? And I said, probably not. But it's useful to act as if it does. And I really believe this, that all numerical probabilities are just constructs, like the numbers you've been using. They're just constructs. They're essentially subjective. We can check how good they are, as we've just done. And only rarely could these be considered estimates of true chances. I mean, lotteries and gas molecules, and very rarely those situations occur. And even in those situations, ironically, these are actually deterministic. A lottery balls is deterministic. It's just very, very complicated. But I should say, I'm not talking about the quantum world. That is really different. Probably some people would say that probabilities for subatomic particles actually exist. But others have strongly argued that even those are relative to an observer or other particle. So even at the subatomic level, these probabilities are not fixed objective quantities. Okay, so that's my little bit of philosophy. So I rule my life by 2 aphorisms. All models are wrong, but some are useful. And probability probably doesn't exist, but it can be useful to act as if it does. That's what I believe. Okay, so just as an example, during COVID in the UK, there was a very influential clinical trial when they gave dexamethasone, which is a cheap steroid, very cheap steroid, to people in hospital with COVID-19. And they found for those on mechanical ventilators, it had, produced a huge improvement, 36% improvement in the daily risk of dying. And they calculate various intervals and p-values, but their assumptions are quite strong. They assume independent observations, each with common risks. And this is clearly untrue. These individuals are not independent at all. They don't all have the same risk. It's really untrue. People will vary. People treated similarly in one hospital close in time will be correlated. So this analysis is based on untrue assumptions. So we know these numbers are not correct, but the effect is strong enough to be robust to more realistic assumptions. So I think we should have some humility about our analyses, realizing that none of the numbers we calculate are actually correct because they're all dependent on assumptions. And where that I think this is a beautiful example, a really beautiful example. In the UK during COVID, everybody was trying to estimate the R number, the number, the R number, the number of people that somebody infected would go on to infect. And the UK, it was like Obama, he had multiple teams, not just one team, they had 8 teams. There was Warwick and Imperial and London School of Hygiene and Edinburgh, I think, teams everywhere using 12 models to try to estimate, or Cambridge, estimate R. And these are the estimates they came up with, the coloured ones. Now, most of the intervals don't even overlap. They can't all be right. They're trying to estimate the same quantity. So all the intervals are much too narrow as they assume the truth of the model. So any particular team, their results are misleading, a single team. But they all got together and produced a pooled estimate,
Okay.
which is shown there. And then they published all the results. I thought which was really honest and open science. And from now on, now I'm really convinced that it would be great to have multiple teams analyzing the same problem because an interval that is calculated is always too narrow. So for me, that was a big lesson, a big lesson. Um, so I just a bit of discussion, is almost management speak. There's the idea of a red team, and in Obama, there was one team that thought there was only 30 to 40% chance that bin Laden was in the compound. This might have been a red team, or a team that deliberately tries to challenge assumptions and beliefs, identify flaws in logic. They're deliberately critical and pessimistic, and they argue. Really powerful idea. And the UK Ministry of Defence encourage that red team idea of, you know, be, point out the problems, try to break the groupthink, try to identify the confirmation bias. So I think again a red team, and I think we need red statistical teams that test assumptions and say, well, what if this was not true? Well, how different would the answer be?
Mm.
So I think a red team mindset is very good within statistics. Okay, so estimates and intervals, I think are not enough. Um, I've said all this. They're all calculated. I needn't have said they're all wrong. They're all too narrow. So what do we do? So I said all that already. So what do we do? One option is to have multiple analyses,
Mhm.
which I think is very good. Another option is to allow, if there's only one team, is to allow them to say, well, we don't actually believe our results. We not completely. We allow to express our confidence in our analysis and how strong the evidence is. And this has become very popular independently in many areas that people will do an analysis and then say, well, it's not that great, or it's really good. We really believe our results. So in health, there's a grade scale, which is a sort of star rating on conclusions. In climate modeling, people talk about the confidence in their conclusion. And in UK policy, people use a scale low to moderate, moderate to high, or high in the confidence in their analysis. And we found this. Worked on a very important public inquiry into people who got infected blood between 1970 and 1991. A lot of it taken from American prisoners, many of whom had HIV. And so it was a huge scandal, and we were asked to estimate how many people had been infected and how many had died. And when we did the analysis for HIV, we'd really high confidence in the analysis. We could count them, we knew the numbers pretty well. For hepatitis C, we'd built a big statistical model, a Monte Carlo analysis used with a lot of assumptions in it. And we did our best, but in the end, we only had medium confidence in our analysis. And when we were asked hepatitis B, the data was terrible. It was awful. We had no real idea of what was going. This was 50 years ago. We were trying to look at what was happening. And we refused to answer the question. We said the data and the evidence is so bad, we have such low confidence in our analysis, we refuse to answer the question.
No.
And this was very liberating because we'd been asked this specifically, how many people got hepatitis B? And we said, we're not going to try to answer. We just don't know. Because we could come up with a number, but it would be so, we would have such low confidence in it, we would not want to use it. So this, I feel, is very liberating, particularly when you are working in what's called mandated science, when you're told to answer a question. It's not free research. You are told to try to answer a question. Okay, so just to finish off, I'm, really concerned about trustworthy communication, and we wrote some rules for this, some guidance, which we got into Nature during COVID, that as statisticians, I think what we should be trying to do when we communicate our evidence, and we should be trying to inform people and not persuade them. In other words, to raise the level of the discussion, not trying to tell them what to do. And we should be balanced with the benefits and the harms, the positives and the negatives. We should be upfront about the uncertainty. We should be clear how good the evidence is. And the final one, which is maybe the new one, is we should try to what's called pre-bunk misinformation, or the other way to express that is to preempt misunderstandings. So you tell people what the data could mean, but you also tell them what it doesn't mean.
Okay.
This data does not, you cannot conclude from this data that X, because people will misinterpret it either accidentally or deliberately. So you want to get in there hard first before the misinformation, before the false claims come in. We were doing, I got a whole story about how President Bolsonaro in Brazil was misunderstanding British statistics on COVID because they had been badly communicated. So I think this preempting misunderstandings is a really good lesson for statisticians. Say what the data does not mean, not just what it does mean. So I think it's a big new lesson for statisticians. And we tried to put that into practice during COVID with the AstraZeneca vaccine when it was being linked to blood clots in the brain. And we produced this infographic, which took us 3 days intense work to produce this, which just showed the benefits on the left and the harms on the right, and the fact that the benefits increased, really rapidly with increasing age, but the harms increased as you got younger. So they were crossing. And so for young people, it got very close. And so when they discussed this, they said, so we're recommending the vaccine isn't given to younger people. And it was such a strong image that people said, yeah, fine. There were no complaints. And we knew that this was a successful statistical graphic, partly because it was used on the main BBC television discussion. Oh, I haven't got it. Oh no. Oh, I got it. I should have another slide. Okay, the next slide I should have had shows that everyone copied it.
Yeah.
Everyone copied it. It was in Italian, it was in every language. Everyone just copied it because it was so good. And so we knew we'd got it right because everyone copied it. Okay, final slide. Communication in crises. Again, you might think this is not a statistical issue, but this guy, John Krebs, was in UK when we had disaster after disaster. We had foot and mouth disease, we had mad cow disease, we had everything. And he developed a sort of list of points that he's talked about since. That when you're talking to the public in a crisis, you say what you know, and then you say what you don't know. You admit your ignorance upfront, upfront. Then you say what you're doing about it. Then you say what people can do in the meantime to be on the safe side. But then the final thing is the most important. You say the advice will change. So you admit your uncertainty and you admit your provisionality or whatever. I'm not sure of a good word for that, that things will change. And this is such a powerful idea. Politicians find this impossible. They cannot admit things may change. And so they're stuck with policies ages after they're shown to be the wrong policy. So this kind of humility, I think, is very powerful. So conclusions, trustworthy communication is really important to try to inform rather than persuade. And this is true, so true for statisticians. To be balanced, quality, strength of it, preempt misunderstandings. And but finally, aiming for safe uncertainty. I won't talk about that now. Come for that in the questions. Okay, right. I'm going to stop there. Right. Oh, good.
Thank
It got some time.
Thank you, thank you. I would like to go back to some key points that do are one is that you are suggesting in a way that to work with a team instead of just on your own.
Well, I mean, it's expensive to have multiple teams tackling the same problem, but I think COVID shows incredible value of that. And we from because they bring people bring different perspectives, and you might have some very critical groups, but it is expensive. Usually, it's just one team trying to answer a problem. But in climate change, there's multiple teams around the world all doing the modeling, and that's incredibly valuable, I think. So to have, independent teams. And the teams really shouldn't speak to each other until till the end. Yeah.
Okay.
Mm.
Like a simulation, but
Yeah, it's almost wisdom of crowds, or it's getting multiple perspectives rather
yeah.
than a single perspective on something. And I realized that's why I always want to work in a team. I always want to talk to people because I don't want to rely just on my judgment. And in any statistical analysis, as I hope I've shown, there's huge amounts of judgment that goes in. Yeah.
Great. The other one that I wanted to highlight is because from my perspective is I actually was thinking in the possibility of the articles, the scientific articles, to have actually a section where researchers declare like some sort of a state of mind or what are their beliefs or
Yeah.
how they actually think about the problem beforehand, just before, but just yeah, before going through the whole
Yeah.
thing. But what do you think about it?
I think I would love to know what someone's personal beliefs and biases were before they started the study. Why did you do this? But I don't think you could
yeah,
expect an honest reply, because a lot of scientists have made up their mind. This is what I want to find. They
okay,
do not have a completely open mind. They want to find something. Of course they do. And so I think it's a bit of a play acting when you write a scientific paper as if you did it with a completely open mind. But this is the problem because we know that statistical analysis can be manipulated by all these little choices you can make about the variables you include, the data you don't use, the assumptions you make. You can change things so much, which is why in experimental studies now you need a pre-registration saying what you're going to do, how you're going to analyze the data because we know that people can manipulate the results.
Does any of you guys have questions to share or
I
comments?
actually have a question. I don't know how personal this might sound, as in, so I work in a regulated atmosphere with medical devices,
Oh yeah.
and I work as a safety risk manager
Mm,
in a diabetic related manufacturing procedures and
wow. Okay.
devices. So you might have a name already in your mind. But so in general, when it comes to risk management, we rely a lot in qualitative approaches, but also kind of semi-qualitative ones, right? And most of the time they are related to like this uncertainty, and at the same time, we try to be certain about some probabilities as you also express yourself. And of course, it's difficult sometimes to really capture, like, I don't know, the epistemic uncertainty in a sense, because we are following this kind of, it's kind of like a full short, like to capture that in a sense. And we do rely a bit in post-market data most of the time. But my question is, how can like be word here instead be word here, how the Bayesian risk modeling can actually help, let's say, improve the approaches in general? Because at the time, I do believe that indirectly we are already using certain Bayesian thinking, not
Yeah.
necessarily modeling itself,
Yeah.
but thinking. But of course, it's a very heavy regulated atmosphere, so it's kind of difficult also to see where's like the line in where we can actually go for it or not.
Yeah.
And I don't know, I just want to know your experience in this area, if you
Yeah.
most likely have heard about it as well.
Yeah. No, it's really difficult in healthcare regulation because it has to be, people have to pretend there's no judgment, subjectivity. And yet there is lots of judgment and
Yeah,
subjectivity, but they have to pretend there isn't any, that this is an objective regulatory process, etc. But this is actually, it's not true. It's not true at all. And so I think it's a problem that, in a way, it's very difficult to do much about it when people don't admit the amount of judgment that goes into it in this qualitative judgment of uncertainty. And also, for example, in exposures to chemicals, you've got these uncertainty factors or safety factors when you
yeah,
just divide exposures by 100 to get to an acceptable exposure and think, well, this is completely arbitrary. It's totally, it's just a
yeah,
is just
guesstimate.
option. But because it's in a way it's a that's what there is an accepted process, then it's defensible. So I
Hmm.
think that is the problem with any regulatory process is that it has to stand up to scrutiny afterwards. And so
Hmm.
everything has to be justifiable even if it's very conservative, or there just has to be a way to do it. And I think that is the problem when things that are essentially judgmental have to be codified and regularized to make them look as if they are completely objective. And I think it's just a problem with the circumstances. I mean, ideally, yeah, you'd be making probabilistic judgments, you'd be putting that into there, and you would say, we have got high confidence in our modeling, and you do sensitivity analysis to different
Yeah,
assumptions, and you do a proper analysis of a safety case. But without that, but then trying to defend that against the manufacturer or something
yeah,
that would be very difficult. So it's easier just to have, rules of thumb, arbitrary rules to do it. But
yeah.
it's not scientifically correct. Yeah.
Yeah, no,
I'm
I
not being I'm not being much help, I know, because it's
no,
very
it's
difficult.
okay. At least,
Now,
at
I
least I.
and I fought with this myself. Although, Bayesian methods in clinical trials are increasing. I've been worked in this for years, 40 years or so, and but now no, a lot more acceptances and in devices as well,
Mhm.
because the data just isn't good enough to answer all the questions.
Yeah. Yeah, no, I agree. And I just want to kind of highlight as well when you mentioned about the red team mates, let's say, because of course I also work very interdisciplinarily, which means having a lot of opinions or judgments, let's call
Yeah,
it that way.
yeah,
And I do agree with the approach of having this really adds a lot of value also within the whatever judgment or conclusion we're trying to reach.
yeah,
Because at the end, it's really, I don't know, like relevant in a sense to make a proper assessment, not just based on, oh yeah, we all want to be in the same boat in a
yeah,
sense,
yeah,
but
yeah,
we
yeah.
also need to face up each other. So
I, yeah, that's why I think it's so interesting the Osama bin Laden question, and but some people definitely think, oh, they should all have got together
yeah.
to present a unified opinion to the decision maker. I think this is completely wrong. The person who takes responsibility should know that there are different opinions. That's part
Yeah.
of the job. Yeah, yeah,
Yeah, no, I agree. And I didn't know the term, so now that I know, I'll probably use it more.
yeah, yeah,
So
yeah.
thanks for that. And yeah, no, I keep my notes for sure, but just in general, I want to express my gratitude, of course, of you taking the opportunity to talk with us and also to give us a little glance. I know it's like all of those years of experience cannot be shared through 1 hour of
Well, there's a lot.
but of session, but it's rather good. So
Yeah,
thank
you're
you very
quite
much.
right.
I
But
appreciate
I have been trying to put about 50 years of experience in this book,
it.
which is why,
Fair enough.
well, which is why it's too long.
Yeah, yeah, yeah. But no, but thanks for that, really. I appreciate it.
No, not at all, not at all. Yeah.
Someone else want to share something? Brian?
Yeah, I have one question. So where do you think statistics going in the future? Because as you were saying, everything of our analysis is based on our beliefs. So I know that you already said that the B word was prohibited in this meeting, but I was thinking about it, like, I would say that it is something that we should take into consideration when we're doing articles and investigation, actually.
Yeah, yeah. No, I think statistics, uh, I mean, and within, machine learning and AI, so Bayesian thinking is just becoming fairly standard, of course, and it's very natural that it will do. But I suppose my appeal is that even within more traditional sciences, the one should be more upfront about the assumptions being made and the judgments being made, and not to pretend that this is some uh, objective algorithmic process to do the data analysis. And that means, I think, lots of sensitivity analysis to different assumptions, because we know all the assumptions are not correct, and having some humility about our our estimates and and especially a width of our intervals, which are always too narrow. And so not really I always find it difficult because you're doing something without actually believing that it's strictly correct. And so and that can sound rather untrustworthy, but I think in the end you have to do. We've done our best, and we don't believe this is the truth, but we think this is good enough to answer this question, to be confident about this. And rather than pretending that the analysis is absolutely true and correct, because it's not. And I think one can do that in an analysis by being clear about the assumptions and again coming back to sensitivity analyses. Yeah.
Thank
And,
you.
and
Thank you.
again, not over claiming. I mean, if you've got p equals 0.04, for heaven's sake, it's ridiculous. Or any of the, I mean, p values are pretty absurd anyway. But especially if they're very close to a boundary, because I only really understood this recently. I think because of Andrew Gelman that when we teach p-values, we say, oh, it's the probability of getting such an extreme result under the null hypothesis, and we forget that the null hypothesis is not just the parameter equals zero or no effect. It also includes every assumption in the model, the independence, the regressors we're using, everything about the model is part of the null hypothesis. So it's only under the truth of all of those that the p-value is correct. And we know those aren't true. So it's, I've only recently really taken that on board, I think. Because when we teach this, that when I've always taught this, we only condition on the parameter, being zero or no effect. But that's not the null hypothesis. So,
Okay. Yep. Thank you so much. I just wanted to make a comment because I find this really difficult, especially when we're talking about politicians, Like I work in a public institution here in Costa Rica, and it's really difficult for me to understand when they're using indicators and they're saying that that's going to affect in the future the universities, and I find that it's not true, Like I find it really hard. So yeah, I have been trying to change my way of belief and my way of making the statistics and trying to explore more that and try to communicate that to the people that we're making decisions in our beliefs, not in something that is written in a paper and it's just like that in stone, like we'd say in Costa Rica.
on stone,
So
yeah, it's
yeah,
not written on a tablet of stone. That is I do a lot of talks to British civil servants, officials, and they always say, "Oh, the real problem is our politicians. They want certainty. They want to know what's going to happen. They don't want to, and because they think that if they admit uncertainty, people won't trust them. They won't listen to them. I want to be certain." And this is ridiculous because,
yeah,
good, trustworthy people can admit uncertainty. And so I kind of, there's something I now argue with with the civil servants, the saying you mustn't give in to this. You must say, sorry, we cannot give you that certainty. It's impossible and unrealistic, and we're not going to do it. You have to stand up for them to it and to be open about the uncertainties and the judgments that go into this. Um, and and that's difficult. It requires a cultural change, which is difficult in our country as well. So I think this is a long-term thing. But I think it's part of being a statistician. I think that's why I emphasize the communication more than the analysis now, because I think statisticians uh, just doing the analysis or writing the paper is not the end. It's the
yeah,
beginning.
yeah,
You really should be taking responsibility or thinking about what happens afterwards. What is going to be done with what you've done? And try to make sure that what is done is responsible and understands it. So it's not the end point, just writing the paper or writing the report. That's not the end. Even though when I learned statistics, that was definitely how I was taught. That's the end. You have no further responsibilities at all. But I think that's wrong. We can't live like that anymore, I don't think.
yeah. Thank you so much for the time.
No, thanks. No, thanks. No, I feel your pain, as we say.
Yeah, it's really hard actually because
It's hard.
I work here and sometimes I'm like I don't know why these people is taking that like just like it's like that. I don't really get it. Like and when you try to express, they find it difficult.
They do. I think because they don't have a language for uncertainty. They think it shows weakness
Yeah,
or stupidity or being untrustworthy. So you don't have a language. But really good communicators can do it. Really
yeah,
trustworthy, it can be done. But it, it is challenging, I think, and people don't have a language for doing it. Um, and I think, yeah, they need help. Yeah.
yeah. Thank you so much. I'm gonna write that in my mind. Communication is the most important,
I think it
Yeah.
is. It's what I feel now. As I've got older, as I
Yeah,
stopped doing the analytic stuff,
yeah.
the communication for me has become so important because I get so upset and angry at the misuse of statistics, the misinformation, bad claims. It makes me so angry that I kind of think, well, statisticians have some responsibility to try to stop that. Yeah.
Yeah. Thank you, David.
I was about to ask something else, but I think you already kind of answered my question because, like, in the context of AI itself, I think, and yeah, you kind of already answered. Uh, is it really like this key element of having AI without uncertainty really something irresponsible in a sense?
Yeah.
Because we do rely on it at the end, but how is like how can we make, let's say, AI modeling most trustworthy in a sense?
Yeah, no, it's that is so important, and that's a big, big problem beyond our work. But I think that yeah, I used to work on AI and uncertainty 40 years ago, and we thought we'd solved it because we showed how Bayesian methods could be used within AI. But these were quite small problems with just a couple of hundred nodes, and you could have all the conditional probabilities. But with a large
Mhm.
language model with billions of nodes, they can't propagate probabilities through them, and
Yeah.
that's not how they work. So people are really trying to explore how to bring some measure of uncertainty into large language models, rather than just saying at the bottom, this may be wrong, which is not responsible enough. And that's a serious point and I really feel this is useful. But the other side of it is, I think that where I see a benefit of AI is that provided that it's not manipulated by Elon Musk or someone like that, that it can in fact give quite a balanced judgment. I like using AI. It may be wrong occasionally, but I find it tends not to be biased.
Yeah.
It will give you a broad view. It's not biased, it's polite. I like talking to it. I prefer talking to it than many humans because it's so nice to me. And it doesn't get cross when I keep on asking the same stupid question. So I like talking with it. And so it may be wrong, and I may, about facts, and I may have to check things, and I try to do that. But at least I feel it's not being biased. So I think that in the future for statistical analysis, I think AI could be extremely valuable, and it could even have built into it, um, some packaged warnings about, not taking this too serious, about interpretation of p-values, about all this. It could have a lot of stuff built into it. So I think it's got great potential as a source of unbiased information, provided that the owners don't start manipulating it.
Mhm.
That's why I won't use Grok, Elon. I won't use them.
Noted.
Yeah. Yeah.
Bueno,
Yeah.
no sé. So, someone else, do you want to, Jimena, Priscilla, Jose, Isaí, do you have any shares?
You don't have to. It's fine. Been a good discussion. Been a good discussion. Yeah. Yeah.
Yes. Well, I wanted to ask for an advice. Well, maybe what I'm trying to say is that I think we were very obsessed in a way as statisticians to overcome the technological part of estimating probabilities
Yeah.
and so we had like an age of developing machines
Hey, yeah. Yeah. Yeah.
and now it's like and we are returning to the essentials
Yeah.
basically.
Absolutely right. That's a really good point because I know I've been part of that revolution, been fantastic, from 1990 working on Bayesian computation, and suddenly you can do things. So now we can do so much. And I think you're right that we're coming back to the much more basics of what are we doing? And can you believe the data? I now get obsessed with, rather than just analyzing data, where did it come from? Can I believe this? Who collected this? Why did they collect it? Why am I being told this? Why am I being asked this question? So I think you're absolutely right that it's now the technicalities are not the issue so much. It's much more a matter of what are you actually doing and what use is it? Yeah, it's much more thinking about the whole process from setting the problem. To what question are you trying to answer? Can you answer the question that with the data you've got? which I think is a really important because people to ask you questions, politicians ask you questions, things like that. And I think, as I wanted to show, sometimes you have to say, I can't answer. I'm not even going to try because the data just is so bad that it would be professionally unacceptable. You just can't answer. Sometimes you can't answer. So you have to be able to say that. You know, so it stops right there, the analysis, the whole thing. You don't carry on through the cycle. Yeah. And I really like this whole data cycle of setting the problem, planning the study, collecting, getting the data together. Then you got the analysis, which we focused too much on, I think, in the past. And then you got the conclusions and the communication. And that whole cycle, the bit that we always teach to our students is just that little bit of the analysis. And it's so much bigger than that.
So yeah, suddenly, yeah, we have room for to think about in this way. I actually like to add like three sections on the methods part of an article that it's one is the specification of the model where you actually should state your assumptions and
Yeah.
things that are how are you relating the variables. Then the machinery that is like kind of how you calculate it.
Yeah.
And then there will be room for an interpretation, and this should be redefined as you are making it clear in the stock, like what can be interpreted and what cannot
What
be.
cannot be? But the main thing is you can't leave that to the bottom of the paper in the small print. That has to be up front. And within British national statistics, I hope there's going to be a change so that on the websites and in the releases that go to everybody, it will say very prominently right at the top what this data does not mean.
It's
And
like
that
after the title it should be.
yeah, well, you should say you should help people interpret it, and but part of that, a major part of that, is to help them understand what it does not mean, what you cannot conclude from it. And I think this is a really exciting development and something I'm pushing a lot, and because it could change the whole way in which one thinks of communicating the headlines, right? Well, just slightly below the headlines, that you try to, avoid the misinformation, the false claims right from the beginning. That's in your mind, not at the bottom, not in the small print at the bottom. No, no good. Nobody reads that. Nobody wants to tell the story will read that. People, statisticians might read that, but if you want to make sure that your work is not misused, you have to get up there and say what it does not mean.
Right. Do you want to share anything else? Is there something you want to?
Oh no, actually, this has been great because you've got all sorts of ideas and things that I'm thinking about at the moment. So this is it's slightly old man talking, but I'm still, I still think I think this is important stuff. I mean, you have to know the technicalities as well, of course. You have to do the serious work, but the communication, which includes the whole process of what you've done, I think is absolutely vital. Yeah, yeah. No, I've had enough. I need another glass of wine.
Have you been enjoying it then?
Yeah, yeah, yeah. So this has been great. No, really, really good fun. And I'm just sorry I'm not in Costa Rica. But
Yeah,
never.
well, that's what I was gonna say now. Well, what I'm drinking now, it's actually coffee, not
Yes, of course it would be. Yes, quite right.
so. But we were actually thinking in how to get you some bags of coffee to Cambridge.
Oh, that's very sweet. No, the problem is I drink Costa Rican coffee all the time anyway, but I'm sure it's not. I'm sure it's the scrapings, the worst stuff we
I
get.
think so. You might be getting one of the good ones from.
Yeah, yeah, I don't know. Yeah.
Well, the other day I was actually learning about it, and apparently there is a scale of three categories where there's the
Right.
commercial, then there's the gourmet, and then there is a type of coffee where um, it is tractable. Basically, you can know how they actually did the process of
Oh,
harvesting
okay.
and drying it, and all of this information goes to a type of coffee production that makes it like the
Right.
highest top. But is the flavors there might change a little bit, and so this is high. This is why basically they don't serve it in commercial
Yeah,
cafeterias.
I don't think I'm enough of a connoisseur to judge all this. Yeah, I
But
just
yeah, you should. We should arrange next time to for you to come and give a talk here in Costa Rica. But press.
if I will let you know. I'd love to. I've never been to Costa Rica, and one day I'd love to come. So I shall let you know if I come. Yeah, yeah.
All
Okay.
right. Yeah. So and then we can give you a coffee tour also here.
It's so nice to meet you all, and yeah, best of luck. Best of luck is all I can say.
Yeah, I've enjoyed a lot your talk. It's all the time very rich to talk to you, and everything you share is full of knowledge and full experience, and it is nice to actually know that since you have all that background now to get to interchange with your reflections after all of this work that
Yeah,
you've done.
yeah,
It's
and
very
it's
nice.
not. I find it's an odd mix because it's a mix of very practical things about communication. At the same time, I'm even more interested in more philosophical ideas about what probability is. You know, what are we talking about? What do we even mean? So that's going right back to what I was learning when I was 20 from De Finetti and all that kind of stuff. So I'm still interested in those really foundational issues of what this really means. So it's an odd combination, which is nice, very nice. Yeah.
Well, and if you like this interaction, then we I can offer to meet again soon, sometimes I don't know, and just talk about things and do some philosophy,
Some philosophy. I'm very amateur. I'm very amateur. Yeah.
just
Yeah.
to interchange about ideas. It's all
Yeah.
the time nice to talk to you anyway.
No, no, it's great. It's really nice. So I'm going to leave you to what time is it for you? What time is it?
Here is about 2:12.
2:12. Okay, 9 hours. Right. Okay, good. No,
So
no. Yeah, no, 7 hours. 7 hours. Yeah, 7 hours. Right. Okay. Yeah. No, quarter past
thank
nine.
you. So
Very nice. Bye bye. Nice to see you all.
Thank you so much, David.
No, not at all. Bye bye. Bye
bye
bye.
bye. Thank you.
Thank you so much. Bye.
Ciao.
Chao, profe.
Nos
Gracias.
vemos.
Un
Chao.
gusto.
Just
Chao, chao.